Okay, this is Algebra 2.1, Section 2.7e. This is really about notations. We've worked on these quite a bit in class, but I just wanted to review them just a little bit with you in case you haven't been in class. So I'm going to grab a sheet of just regular paper and explain them. And of course I didn't find that. Let me grab one quickly. Let's say that you have an inequality that looks like this. This is -2 and 5. I just randomly grabbed those values. Okay? So the way to show that as an inequality would be your x coverage is in between those. It can be equal to or less than 5. It can be greater than, but not equal to -2. Now, if you were going to show that in interval notation, the way that you would show that is because it cannot be equal to the -2, it's a rounded parenthesis, then the -2. And because it can be equal to 5, it's a bracket, and then the 5. And you simply put the comma between. That's interval notation. Now, if you want to do set notation, it would be set sign x such that -2 is less than x is less than or equal to 5. Set sign closed. Okay, let's do one more, or actually two more. Let's say we have a graph like this. And let's say that's at -8. So our inequality would be that x is greater than -8. Remember, as long as your variable's on the left-hand side, this arrow tip always matches that arrow tip. Okay? Now we say, down on this end, it's not equal to the -8. So you just put a -8. This kind of matches your graph up there. It goes on to infinity, so we do the infinity sign. And you can never equal infinity because it's not a value. Okay, now for set notation. Set symbol, x, such that this time you have to be a little bit careful because your lower limit, going back to your graph, is -8. Your x is up on this side, and I'm sorry, I shouldn't have put that line underneath. It can't be equal to 8. Now, what's beyond the x value out here is infinity. So you have to show this in set notation as a complex inequality. Complex inequalities always have less than signs in them, never greater than. So just turn the whole thing around, flip this whole thing around when you come down here. Last one that I want to do, let's say we have a graph like this at 100. And again, I'm just randomly making those up. So we would have that x is less than or equal to 100. Equal because it's a closed circle. Our interval notation, going back, I like to go right to the graph to match it. Because it's equal to the 100, I put the bracket, the 100. And now it heads down that way, which is infinity, going that direction, which is -infinity, rounded parenthesis. Again, the set notation would be set notation x such that, and now we have to put it in the complex inequality. So I go back to the graph. My upper limit is 100. My lower limit is negative infinity. Put the x between them, and we always use less than symbols. This one, because it can be equal to, has to be underlined. End of set notation. Okay. Now, that covers what this page in your notes is talking about with your notations. If you need me to further clarify that, come by and see me. And now we go to a piecewise graph. Piecewise graphs, I just want to cover real quickly, and then we'll practice more in class. A piecewise graph is really what it says. It's pieces of graphs. So we have our y, or our function of x-axis, which would be right up here. You can also label it as y. And then we take the pieces off of there, and we might have, let's say 3 and negative 1/2 x plus 4. Now out beside this, I shouldn't have written it that close to the margin, but out beside each of those we would have our limitations. So after the 3 we might say x is less than 2, and maybe x is greater than or equal to 3. So don't worry about those windows, those limitations. Let's just hide those for a minute and just look at the equation here. That would be f of x equals 3, or y equals 3. Remember from in class, we've talked about whenever you have only one variable, it cuts right through that axis. So we go to the y-axis, we go up to 3, and I'm going to have to use a pin for it to show up on this camera. Maybe it'll show. We would have the, actually I better go back to pencil because we're doing piecewise. We would have the graph going right through the y-axis like that. Okay, now we go to the other equation. It's negative 1/2 x plus 4. Remember, y-intercept is plus 4. So go up to 4. The slope is negative 1/2, which is rise over run. We always rise, so we go up 1. But since it's negative, we're going to go to the left 2. So then you would get a straight edge. And you would go right through those 2 points. Don't need to make a real heavy line quite yet. And now we look at our windows. For the first graph, y equals 3, we said x is less than 2. So we go to where x is less than 2. There is 2 on the x-axis. We're saying less than, so it's going to go from there down. So from there up, you erase everything. Now it does not say that it can be equal to 2, so we put an open circle on the 2, and then we darken the arrow tip. Darken that whole line. That's where that one is going. The next one says negative 1/2 x plus 4 when x is greater than 3. When x is greater than 3. Now I do say that it can be equal to it. So now we go out to 3 on the x-axis. We come up to that line and we put a solid circle, and it can be greater than, so we darken that line. We erase everything before it. And that's piecewise graphing. I will do one more, very quick one, to try to fit it in this area. F of x is equal to 3. And let's say x is greater than or equal to 5. And then let's do 3/4 x minus 4, and x is less than or equal to 0. So the first line, f of x is 3, that's the same as y equals 3. So we'd come to 3 on the y-axis, cut right through there. Now we look at our window. Our window is that x is greater than or equal to 5. So we come over to 5 on the x-axis. We're saying it's going to be greater than, so it's out that way. So we come up to our line. It can be a solid circle because it says it can be equal to, and darken it. Okay. Erase the other part of the line, and we're done with that one. Now we go to the other one. 3/4 x minus 4. Minus 4 is our y-intercept. 1, 2, 3, 4. Put a little point. 3/4 x, so we would rise 3. 1, 2, 3. And run 4 to the right because it's positive. 1, 2, 3, 4. And now use a straight edge to line that. It says when x is less than or equal to 0. Here is 0 on the x-axis. So we want it less than, it's going to be going all this way. We erase the line up above. We do say it can be equal to it. So we put a filled in circle and our arrow tip. Sorry, I got a little bit off view. So again, 3/4 x minus 4. We start at -4. And then it goes less than 0 because of the window view. Okay. That is it for 2.7e. Thank you very much.